Okay, so objective 5.1c, our topic is oblique asymptotes. Now, we're still graphing rational functions, and we're just now going to talk specifically about the oblique asymptote. So you will be successful when you can use longer synthetic division to find oblique asymptotes, and then you can graph the functions with oblique asymptotes. So what is critical to remember from the last lesson? I'm going to start with my red pen because you know I color code. So the vertical asymptote, we still have to find that, which comes from the restrictions of our denominator, right?
Yes.
Okay, so we remember that. Then I'm going to switch to my purple pen for my zeros and y-intercepts. So my y-intercepts and zeros okay, so we got to remember those, and we're really good at finding those, so that's not a problem. And then I'm going to pick up just my pencil, and we have to remember that to graph these, we will have to use a table of values. To get the gist of the graph. How is it behaving? Gist is a good word. Have you ever used it before? You got to get the gist of it, you know. You don't have to get the perfection, just the gist. Okay, so that's what we have to remember, not horizontal asymptotes today, because remember what I told you a little bit ago. Horizontal asymptotes and oblique asymptotes don't occur on the same graph of a rational function. What's new? Here's what's new. Green pen. Green, green, green. The oblique asymptote. Sometimes called the slant asymptote. I'm going to label it OA. I bet you knew I was going to do that. Okay, the oblique asymptote occurs when the degree of the denominator, what's that? I don't even know, is greater than the degree of the denominator by 1. For example, x to the 4th over x cubed. We will use long or synthetic division to find the equation y equals mx plus b, the linear equation, the slanted line. Remember, ignore the remainder. We are not going to try to graph a line with a remainder. No, we are not. Because the remainder, here's the thing. With the remainder, when you're plugging in x is 1,000,000, the remainder is so little that it's insignificant, so there's really no need to try and graph it. Plus, this math teacher doesn't even know how to graph a line that has a remainder. I'm sure there's a way. But I don't tend to do things that aren't useful in my life. So there you go. So here we go. Here we have our first function. I am going to give you a little advice that you should probably write down in the left-hand column. Before you actually go to draw your graph, are you hearing me?
Yes.
I hate to say this, but you'll be so frustrated if you don't. Graph the graph with your graphing calculator and look at it. not because I want you to know, here's the graph, let me copy it down. That's not why. It's because sometimes the graphs are so far up and down the y-axis that if you create a graph that goes from -10 to 10 on the y-axis, you might not have anything to graph at all. Like you plug it into the graphing calculator and you press graph and you don't see anything. That's because the graphs are just really high up and really far down. So use Desmos or something just to get a visual. Of course, you could do a table of values as well, and that would help you. All right, so that's my advice. Picking up my purple pen first. I'm going to go ahead with purple. Purple pen to find my y-intercept because it's the most readily available piece of information. I can see it right now because my y-intercept is when my x equals 0. So here's my y-intercept. I know it's at 0, -3/2. So that's good to know because I can go ahead and plot that. But I don't know what my graph looks like yet, so we won't plot it yet. Now, I'm going to go to my green pen, and I'm going to do my oblique asymptote. Because look, my numerator is a degree of 2, and my denominator is a degree of 1. And x squared divided by x is x. So that's a line. So I'm going to go ahead and write degree of 2 over degree of 1 means oblique asymptote. And it's definitely a line because the degree of the numerator is just 1 bigger than the degree of the denominator. So what do you want to do this division? Do you want to, ooh, I hear you say synthetic. You guys are on it. All right. So what goes in our little box? -2, right? Opposite, the 0. Yep. All right. And then we go 1, -2, and -3. Remember that I told you you can ignore the remainder? Remember I said that? So guess what we don't have to find? We don't care. Okay, bring down the 1 and divide and multiply. So that's -2, add -4. So here's my oblique asymptote. My oblique asymptote is y equals 1x minus 4. I'll go ahead and put the remainder in there, but again, we don't care. Because we don't graph that when we graph y equals mx plus b. So it's got a slope of 1 over 1, right? And a y-intercept of 0, -4. And remember, that's an asymptote. That's not part of the graph of our rational function. It's just a barrier that our graph will probably not cross. However, it's possible that it will sometimes, one time. It won't cross it 2 times. Okay, so that's what we know so far when we're in the original form of the function. Let's go ahead and do the factored form. So, yes. What, here? 0, -4, it's your y-intercept. Yeah, I can clean that up for you. 0, -4. Better? Okay. All right. So back to my red pen. So I'm going to factor. Yeah. Yes. Oh, that's an asymptote. It's just a diagonal line. It's not part of the purple y-intercept's the actual y-intercept of our graph. This is a boundary line that we're not going to cross, but we do have to know where it crosses the y-axis. I know. When I first did it too, I'm like, wait a second. That's not right. Yeah, good question. All right, so let's factor the numerator. What do you think? Factors of -3 that add to -2. -3 and +1. And so let's take a look at our denominator. Does my graph have any holes in it? No. All right. So now, since we have our red pen out, let's go ahead and just identify what's our vertical asymptote. What's our restriction? Yeah, x can definitely not equal -2. So there's our other asymptote. Then I'm going to grab my purple pen up one more time. And let's go ahead and get my zeros. So where do my zeros come from? When y equals 0? Yeah. So basically, my numerator has to equal 0. Think about that. If my numerator equals 0, what does y equal? What's 0 divided by anything equal? 0. So all I got to do is find the zeros of my numerator to find my zeros. So what are my zeros of my numerator? X equals -1 and 3. Okay, so the zeros are the zeros of my numerator because they would make my whole equation equal 0. So I've got my y-intercept, my zeros or x-intercepts, my oblique asymptote, and my vertical asymptote. Okay, so here's what we're going to do first. We are going to create a scale on our graph. Here's the scale. I want to be able to graph each section of the graph. So would like you to make your scale on your x and y axis by 2. 2, 4, 6, 8, 10. So take a moment to do that. It probably wouldn't be a bad idea to just do this on all of the problems that I'm assigning you today. All 3 of them. That's a lot, huh? Okay, I'm going to press pause and you can come back to the video when you're done. All right, so I'm going to go ahead and graph my vertical asymptote, which was x equals -2. So I'm going to sketch that on my graph with my red pen because it's my restriction. I am restricted red. Always do my restrictions in red. X cannot equal -2. Oops, I moved my video screen. So there's my vertical asymptote. And then I'm going to grab up my green pen and graph my oblique asymptote, which was, x -4. So that's a slope, y-intercept of -4 with a slope of 1/1. I'm going to go ahead and do a slope of 2/2 since I did a scale of 2. 2 divided by 2 is still 1. So there we go. So cruise along your graph. Make sure you go all the way across. You don't have to do all the little points that I'm doing here. You could just see where the graph is going and sketch it. I'm going to get a little bit further on the graph right there. All right. Please label it. Y equals x -4 oblique asymptote. Okay, so those are my asymptotes. That created 4 different regions on the table or in the coordinate plane. So here's what I want to tell you. When we were graphing with horizontal asymptotes and vertical asymptotes, we would pick x's that were to the extreme left and to the extreme right, because we could definitely see if our answers were going to be below or above our horizontal asymptotes. But here, if I plug in -100 and I get a value that's really high, or really, well, if I got a value that's really high, it's knowing I was going to positive infinity. But if I get a value here that's really low, like if I go out to -100 and I get a value that's really low, because this is a diagonal line, I don't know if I'm above or below the diagonal line. So here's the thing that's going to change. When you're graphing with oblique asymptotes, you need to pick x's that you can actually see on the graph so that you can actually see if their outputs are above or below that diagonal line. And I think stay closer to the vertical asymptote versus further away, because the further away you get, the further off the graph you're going to get. You're not going to see anything. So here are the points I chose today for my x, for my table of values. So you're going to go through the same process of plugging it in your graphing calculator, making sure your independent variables on ask, and then you're going to pick your values. So I picked -7, and let's see, I picked -4, and I picked -3. You could pick any values along that left side of your asymptote. However, I did pick negative 2.001 because I did want to see what my graph was doing as I approached my vertical asymptote from the left. I also picked negative 1.999. And you know what I forgot to do? I forgot to graph my intercepts and zeros. So I'm going to come back and do that in a second. I'm going to finish my table of values real quick. All right. And then I also picked 2. And I picked 4. And I picked 6. So again, if you get too far off your vertical asymptote when you're picking your x's, you'll be so high or low off the graph you won't be able to graph anyway. So just keep it kind of tight, close to the vertical asymptotes. Those are the values you want to pick. I'm not going to ask you to write about the end behaviors with oblique asymptotes. Okay. Did you just celebrate that? I'm going to make you do it. No. All right, let's go back and pick up our purple pens and put in our y-intercept and our zeros real quick, because we want to see the gist of the graph. So our y-intercept was negative 1.5, so it's about right there. And our zeros were negative 1 and 3. Well, that's interesting because all of those are in the same region, right? And so I can pretty much see the behavior of this graph in this top right-hand region. I can see it. It starts high, it goes low, and then it starts to get high again. And these graphs pretty much will hug the asymptotes after you get through the curve. They'll get really close to the asymptotes. But let's go ahead and here are the values I got. So I'm going back to my pencil here. When I plugged in negative 7, I got y equals negative 12. When I plugged in negative 4, I got negative 10 and a half. When I plugged in negative 3, I got negative 12. When I plugged in approaching the asymptote from the left, I got negative 5,006. So let's graph those points, yes? So negative 7, negative 12. So you can see I'm below my oblique asymptote. Negative 4 was negative 10 and a half, so still below. Negative 3, negative 12. So you got the curve going on there. So this graph is going to pass through those curves, just the gist of the graph, not a perfect, and then it's going to hug the asymptote. So it's just going to get closer and closer and closer to it. You don't have to make a really big graph or a really long line. Sorry about my train tracks here. There it is. So that's what that graph's doing. Here's what I know. This is a function, so I'm not going to graph anything up here because that would fail the vertical line test and make it not a function. All right, so when I plugged in negative 2, 1.99 coming to the asymptote from the left, I got 4,994. When I plugged in a 2, well, I think I don't even need the 2. Do you? Because I can see what's happening here. Let's not do the 2. Who cares? We already got a point. 4 gave us 0.083. And 6 gave me 2.6. So we'll just graph the 4.083. So that's like right there. Already pretty close to the asymptote. And 6 and 2.6, which is like right there. So here's what this graph's doing. It's way up here. As I approach the asymptote from the right, curving through your zeros and y-intercepts, and then it just really hugs along that diagonal or that oblique asymptote. And that's that graph. There you go. Your first oblique asymptote example. Questions? So not really that different, right? Than what we already know. Except that we don't pick extreme x's, because you see what would happen if I picked like x is negative 20? I'd be off the graph. If I picked x equals 18, well, I might still be on the graph because it's hugging along the graph right there. All right? Okay. So this is why we pick x's near the asymptotes. Next, we're going to change this equation. And I meant to change this equation because it is crazy off the graph. So what we're going to do is just change one number in the numerator from 27 to 8. That looks terrible. I'm going to do that again. Let me get my white pen, and I'm going to color it out. And my black pen. There we go. Looks better. Okay. So, immediate information. Purple pen. Y-intercept. What is it? 8 over, what's the constant in my denominator? No, that's a coefficient. What's the constant? 0. That's undefined. So you know what that means? There is no y-intercept. What? It's probably because what is our restriction? X equals 0. That's right. If x equals 0, doesn't that restrict everything on the y-axis? Yep. Okay. So anyways, let's go ahead and do our division. Because I'm switching to green, because the degree of my numerator is greater than the degree of my denominator by 1, degree of 3 over degree of 2. So when we do our division, we get an oblique asymptote. This time, synthetic division is not going to help us. We're actually going to have to divide. So here we go. 2x squared plus 0x plus 0 goes into, help me out. I don't start with the constant. Negative x cubed plus 0x squared. Plus 8. Yeah. P.S. I don't even need really past that. You're going to find out in just a minute. But that's okay. All right. So we're going to divide. And maybe I'll come over here off to the side. Negative x cubed divided by 2x squared. Simplify that. Isn't it negative half x? Yeah, negative half x. Okay. Right? Because, yeah, that cancels that out, and that's a negative 1. So negative half x. There we go. So we multiply, and that's negative x cubed. Negative half x times 0x is, that's 0x squared. There aren't any. And then negative half x times 0, that's just 0x's. There aren't any of those either. Then we come back in, and we subtract. So we're going to change all the signs. Cancel the first part. Bring the second part down. You have to. So 0x squared. I don't even care about the rest because I don't need the remainder, if you recall. I have y equals negative half x. I should be doing that in green. Let me go get my green pen. Y equals negative half x. So far, that's my slope, right? All I need is my constant to get my y-intercept, and then I can be done. So 0x squared divided by 2x squared is what? So plus 0. I don't care about anything else. I can be done because my remainder is going to be so insignificant as I get closer to infinity that I can't graph it anyway. So there we have it. So there's our oblique asymptote. Y equals negative half x plus 0. Okay, now let's go get our horizontal asymptote. No factoring happening here. I don't want to factor to find the zeros in my numerator. Factoring cubes, that just gives you 1 0, and then it gives you 2 imaginary zeros. So we don't need to factor our cube. Let's just go ahead and find our vertical asymptote. What will make our denominator equal 0? 0? Yeah, so, because, 0 is our restriction, for sure. Okay, and then I'm going to grab out my purple pen one more time to find my zeros, which come from my numerator up here. Okay, so that's my 0, but I'm going to bring that problem down here so I can actually find it. So if my numerator equals 0, our equation equals 0. So our 0 is coming from 8 minus x cubed equals 0, and we're just going to solve for x. And I think I can use the cube root property to do that, right? I can just add x cubed to the other side. So 8 equals x cubed, and then I can cube root. And 8 is a perfect cube, right? So 2 equals x, so there's our 0. So we don't have a y-intercept, but we have a 0. We have a vertical asymptote and an oblique asymptote. All right, so here's what I'm going to tell you. This time, we can go ahead and do a scale of 1 on your graph, so we don't really need to label it, okay? Because we'll go with a scale of 1. This graph stays pretty well on the graph. It's not too crazy. So let's go ahead with our purple pen since we have it out and graph our 0 at 2. And then grab your red pen and get your vertical asymptote graphed. And then get your green pen and graph your oblique asymptote. What was it? 0, right?
Yeah.
So we're going to deny anything crossing the y-axis because that is a restriction. So x equals 0 is our vertical asymptote. So we'll approach it from the left, we'll approach it from the right, but we won't cross it. Grabbing up our green pen. Our slope, our y-intercept was 0. If you remember, it was y equals negative half x plus 0. So it's got a slope of negative half, so it's down 1, right 2. And then you can reverse it up 1, left 2 to keep that negative slope. We graph that. And my pen is really giving me trouble today. You know, every once in a while it just doesn't act right. I know I just need a new one. It's so old. I've had it for like 10 years. Okay, so there's your oblique asymptote. So we don't know too much about this graph. I do think because my 0 is up in this upper right quadrant, that this side of the graph is going to hug these two asymptotes in this section. And I know that I won't graph anything down here, but I don't know if I'm graphing up in this section or if I'm graphing down here. We actually have to do some test points to figure that out. So I'll pick some values and I will tell you what they are. You, of course, will do this on your own later. And we got to hurry because we're getting low on time. So I picked values -6 and -2. And then I approach 0 from the left. And I approach 0 from the right. And then let's see. I picked 3 and 5. Just random x's that are pretty close to my vertical asymptote. So I got these y's. At -6, I got 3.1. At -2, I got 2 and 1/4. At -0.001, I got 4 times 10 to the 6th power 4 million. That's high. On the other side, when I approach 0 from the right, I also got 4 times 10 to the 6th power. When I plugged in a 3, I got -1.05. And when I plugged in a 5, I got -2.34. So these are the points that I'm going to graph. It's excessive. It's too many points, but it's okay. It never hurts to be over careful. -1, 2, 3, 4, 5, 6. Up 3.1. So you see how close that is to your oblique asymptote? -2, up 2.25 or 2 1/4. So it's pulling away from the oblique asymptote because it's turning. And then it shoots way up off the graph. So you're hugging the asymptote, starting to pull away, curving up, and approaching infinity. So there it is on that side. Then on the other side, we're starting up at positive infinity, curving down through your 0. And then I'm going to stop right there. 3 is at -1.05, so it's like right there. And 5 is at -2.75. So you can see that this side of the graph really hugs that oblique asymptote. It gets really close. And there you have that example. different, huh? Question. Oh my gosh, this video is already 30 minutes long. Last one. You poor things, I just torture you, huh?
Yeah.
Oh well, I have the power. Okay, last one. Purple pencil. Okay, so we're going to start with our y-intercept. You see it? Yep. Y-intercept is 0, negative 1/16. And then we're going to have to do some division. So we're going to flip to the green pen. That's a degree of 3 over degree of 2. So that means we're going to get a linear equation when we divide. Therefore, we have an oblique asymptote. And we cannot use synthetic division because our denominator is quadratic. So we divide x squared plus 0x minus 16 into x cubed plus 0x squared, and I actually really don't care about the rest, but I'm going to fill it in anyways, just to reinforce how to do long division. So we divide x cubed by x squared, x, and we multiply, so that's x cubed plus 0x squared. That's not really proper, but I'm saying it so you get it. And then x times negative 16 is negative 16x. Then we go in and change because we're going to subtract all those values and cancel. Switch back to purple, not purple, green. And we get 0x squared. And remember, all I need now is the constant, right? Right? So do I really, really need to write the rest of the stuff? No, because I just want to do 0x squared divided by x squared, which is 0. So y equals, we just divided, y equals x plus 0. So that's our oblique asymptote. That's an easy graph, y equals x, whatever x is, y is. Okay, so now we just need our zeros and our horizontal asymptote, vertical asymptotes. So let's factor. So we get y equals x cubed plus 1, and I don't want to factor that. We could, but I don't want to. Let's factor the denominator. Difference of squares, x minus 4, x plus 4. Correct? All right. So our vertical asymptotes are x equals plus and minus 4. And we'll switch to our zeros real quick. Our zeros are coming from our numerator. I think there's only one in this case. So x plus 3, x cubed, x plus 3, x cubed, plus 1 equals 0. Yep. So x cubed equals negative 1. You cube root those. X equals negative 1. Yep. Cubed root of negative 1 is negative 1. We're going to do a scale of 2 quickly on your graph. So if you want to, you can just go ahead and hit a 2 and a 2 and a 2 and a negative, or negative 2 and negative 2, and we get the scale. Because the bell's about to ring, you can go back when you're on your notes and finalize that. Let's graph your vertical asymptotes real quick at negative 4 and 4. And mostly I just want you to get the gist of this graph. We won't worry about the table of values. I just want you to see what it does. Okay, so we got your vertical asymptotes in there, and then y equals x. It's just going across your graph, cutting it in half. That's your parent function of your line. I hate it when we have to hurry. It is what it is. I always hated it when my mother said that to me. It is what it is. She always says that. Okay. So we get our 0 in there, our y-intercept, which is right there. And what were our zeros? Negative 1 and 3? What were they? Oh, it's just negative 1, right? Shh. Okay. So I'm just going to give you what the graph looks like so that you have a visual. Maybe. It does this. It's down here. And you can do a table of values on your own. You don't need me to figure that out. Then it does this. Hang on. And it's there. Okay? So you can do your table of values on your own. Here's your homework. 29, 30, and 32.